In the previous lecture, we finished chapter 1. For the quiz, only chapter 1 is included. Only the materials which included for the assignment. Okay? It means chapter 1. All chapter 1 will be included for the quiz. Here we have chapter 2. We talked about some basic things in chapter 2 in the previous lecture. We talked about the linear differential equations. This is the general form of n order linear differential equation. And here we said if the right hand side is 0, means if f of x here is 0, we say the differential equation is homogeneous. But if it's not 0, we say that is non-homogeneous linear differential equation. Okay. This is the second order. This is the second order homogeneous linear differential equation. As you see, the right hand side is 0, means it's homogeneous, and the order is 2, so it is order 2, the highest differentiation in the equation is 2. That means it's order 2, and it's linear. That means this is the second order linear homogeneous differential equation. Here the solutions for order 1, we have only one solution. For order 2, we have two solutions. Here, y1 and y2, y1 and y2 are the solutions for this second order differential equation. That means if we have a first order differential equation, we just get only one solution. But for a second order ordinary differential equation, here we get two solutions, y1 and y2. And the general solution, after finding y1 and y2, we say the general solution y equals ay1 plus by2. ay1 plus by2. We just multiply a constant to each of the solutions, then the sum of them is the general solution. And generally, for nth order linear differential equation, homogeneous linear differential equation, we say for this differential equation, as that's nth order, so here we have n solutions, y1 up to yn. So the solution is C1, C is all C, C1, C2, CC up to Cn are constants. As I said, we multiply each solution to a constant, and then we find the sum of them. This is the general solution for the above differential equation, as we have an nth order differential equation. For nth order, we must have n solutions. Here, to find the solutions to homogeneous equation, second order linear homogeneous equation, this is the general form of a second order homogeneous linear differential equation. Okay, as you see here, you have a times d to y by dx squared plus b dy by dx plus cy equals 0. The right hand side is 0. That's why we say that's homogeneous. Here we must find both solutions, and then we multiply each solution by a constant, then finding sum of them as the solution or the general solution for the differential equation. Here we let y to be e to the power mt be the solution for the differential equation. Then this is y, which is e to the power mt. dy by dt, I mean the derivative of this equation, the derivative of e to the power mt with respect to t, yeah, we get m times e to the power mt. We get this. This is the first derivative. And the second derivative for e to the power mt, here we take another derivative for m e to the power mt, and we get m squared e to the power mt. This is the second derivative for y. Okay, now we replace y by e to the power mt, dy by dt we replaced by ma to the power mt, and you replace d squared of y by dt squared by m squared a to the power mt, where into this equation. So this equation becomes a m squared e to the power mt. Is it? Here, this is d squared of y by dx squared. As we said, this equals to this. And plus b, we replace dy by dx, sorry. ده شوية كم دوم بو e to the power mt ورقين داني إنها نانا أي be constant أو coefficient. They are constants. Here we just replace dy by dx by its function. So dy by dx is m e to the power mt. B is a constant. M e to the power mt. It's only driving the general form. Okay. Here we derive the general form. You don't need to do this derivation during solving examples. You just need to write down the general form. Okay. Here plus b m e to the power mt plus c times y. This is c. What's y? Y e to the power mt equals 0. And just to let you know how to get the general form. If we divide both sides by e to the power mt, what we get? In the first term, we get am squared. In the second term, we have bm. In the third term, we have c, and the right-hand side is 0. This is a polynomial of degree 2. This is a polynomial of degree 2. Okay? We divide both sides by mt. Or you can say you multiply both sides by e to the power minus mt. Okay? That's dividing. So now we have a polynomial of degree 2. You have studied this rule. They say m1 and 2 equals minus b plus minus square root of b squared minus 4ac dividing by 2. This is quadratic law. We can solve every polynomial of degree 2 by using this rule. By using this rule, we can solve every degree 2 polynomials. So here we have, this is the general form. That means here we replace. Look, how do you get this? am squared plus bm plus c equals 1 equals 0. We replace the second derivative by m squared. As you see, comparing with this one, with this equation, we replaced the second derivative by m squared. The first derivative by m. And y by 1. C times 1. So generally what we do, we just replace second derivative by m squared. First derivative by m. And y by 1. Okay? We just do that. And then we solve it. We are going to find the values of m. Then the solution, then we obtain the solution. As you see here, we obtain this one, am squared plus bm plus c equals 0. This is d squared of y by dx squared. This is dy by dx. And y is 1. Okay, as you have nothing here, means y is 1. Then we are going to find m1 and m2. After finding m1 and m2, we say here b squared minus 4ac. From b squared minus 4ac, we can decide the type of solution. The type of the solution could be determined by b squared minus 4ac. We say if b squared minus 4ac is greater than 0, means if the terms which in the root is positive, it means we have two distinct real roots. We have two distinct real roots. If b squared minus 4ac equals 0, here we get only one root. m1 and m2 are going to be equal. And if b squared minus 4ac is less than 0, here we get a negative value in a square root. In this case, it means we have two complex conjugate roots. So we have two complex roots which are conjugate to each other. So do you know what's conjugate? In complex numbers, we say a complex number can be written as, let's say, x to be a plus bi. Yes, a plus bi. Then x conjugate equals a minus bi. Our conjugate means our. Okay, so that's the conjugate. Here we have three cases. We have three cases. If b squared minus 4ac is greater than 0, that's case 1. Case 2, if b squared minus 4ac is 0, and case 3, if b squared minus 4ac is less than 0. Okay, we have these three cases. For the first case, we say the solution is a times e to the power m1x plus b e to the power m2x. This is the general solution. But here we just need to find m1 and m2. That's all. If b squared minus 4ac is greater than 0, we say y equals a e to the power m1x plus b e to the power m2x. A and b are constants. A and b are constants. Here we just need to find m1 and m2. How? We replace d squared of y by dx squared by m squared. And we replace dy by dx by m and y by 1. We replace these three things in the equation. And then we can get a solution. We can get the values of m. After finding values of m, which if they are different, if we get two different values or two real different values of m, we use this formula to write down the solution. تنها سابقا ليرة تنها إمانو يمدودو سينو. شيء ليرة أما how can shake my picture? Look, here we have given this differential equation. What we do first, we first write down the characteristic equation. What's the characteristic equation? We replace d squared of y by dx squared. We replace by m squared, and we also replace dy by dx by m, and we replace y by 1. If we replace these three things here, we get the characteristic equation. The equation that we get is called characteristic equation. So first here, we write down the characteristic equation. So the characteristic equation is what? What's the characteristic equation? Who's going to tell me what's the characteristic equation for this differential equation? Just replace these three things here. It's m squared. Yep. Yeah. Yes, equals 0. This is the characteristic equation. Now solve this. If you can factorize it, do it. It's easier and it's faster. If not, you can use the quadratic law. I mean the root here. You can use this rule. If you couldn't factorize it, you can use that rule. Here, it's easy to factorize. Is it? Here, we can factorize it. Equals 0. See, here we have m and m. This is positive. Positive times positive is positive. And positive times positive is still positive. And 6 could be 2 by 3. Can we get the middle term here? So the middle term is 5m. Let's check. 2m and 3m is 5m. So it's the middle term. That means m1, you can choose m1 to be -2 or -3. From this, m equals -2, and from this, m equals -3. Here we solve these two. And from this, we can say m is -2 and m is -3. Let's choose this one to be m1 and this to be m2. May someone else choose this one to be m2 and this one to be m1. It's okay, not problem. Okay. So we choose this one to be M1 and this one to be M2. These are M1 and M2. They are real and distinct. So we apply this rule here. That means the solution is A, we say y equals A e to the power M1x. What's M1? Minus 2x plus B e to the power M2x. What's M2? M2 is minus 3. That's all. That's all. And this is the solution. Here, I'm going to talk about the example again. This example again, as it's solved here. Okay. Yes, that's all. Yes, for the first case, that's all. Look, we say we first find the characteristic equation. This is the characteristic equation. As I said, we are going to replace y double prime, which is d squared of y by dx squared by m squared, and y prime by m, y by 1. That's all. And then we solve this polynomial. You can use quadratic law or you can factorize it. It's easy to factorize this one. It's easy. It's m plus 3 and m plus 2 equals 0. From this bracket, if this equals to 0, then from this one, if this equals to 0, m is negative 3. Okay. And from this bracket, if m plus 2 equals 0, m is negative 2. That means we get two different real values for m, which are negative 3 and negative 2. These are negative 3 and negative 2. So these are different and real. That means it's first case. It's first case. So for the first case, we say if m1 and m2 are not equal and they are real, we use this formula for writing down the solution. We just replace m1 and m2 by their values. That's all. Here, m1 is minus 3 and m2 is minus 2. So this is the solution. We just replace m1 here. We just replace m1 by negative 3 and m2 by negative 2. But you should know this formula. Okay? Try to memorize this. For each case, try to memorize it. This is for case 1. And let's take another example. Here we have another example. First, we should write down the characteristic equation. It's the first step. So what's the characteristic equation? We have y double prime minus y prime minus 11y equals 0. That's another example. So the characteristic equation is m squared minus m minus 11 equals 0. So that's the characteristic equation. Now we try to find the values of m. What are the values of m? Here we cannot factorize it. You cannot make it into two brackets. So what we do, we use the quadratic law. You always can use quadratic law. It solves every degree 2 polynomials. Here we say m1 and 2. So first let's write down a, b, and c. What's a here? A is the coefficient of m squared. B is the coefficient of m, and c is the constant term. Here, a is the coefficient of m squared, which is 1. B is the coefficient of m, which is negative 1. And c is the constant term, which is negative 11. Here, we say m1 and 2 equals minus b plus minus square root of b squared minus 4ac dividing by 2a. We just replace a, b, and c by the values here in this formula. And we get, what's b? B is minus 1. And here we have a negative sign also. That means it becomes minus 1 minus 1 plus minus square root. That's minus b plus minus square root of b squared means minus 1 squared minus 4 times A times C. What's A? A is 1. Times C times negative 11. All dividing by 2A, 2 times 1. Now we simplify it. So M1 and 2 equals minus 1 means plus 1. So it's only 1. Plus minus square root. B squared. Minus 1 squared is 1. Since the power is even, so it becomes positive. It's 1. Minus 4 times 1 is 4. Is 4 times negative 11 minus 44. And we have this negative sign also, so it becomes 44. It becomes plus 44. Is it? Okay. All dividing by 2A, 2 times 1, which is still 2. And it equals to 1 plus minus square root of 45 dividing by 2. Now, 45, we cannot find the square root of 45, but we can make it into the multiplication of two numbers. 9 times 5. 9 times 5. We have the square root of 9, and it is 1 plus minus square root of 9 times 5 dividing by 2. 9, the square root of 9 is 3. So M1 and 2 is 1 plus minus 3 square root of 5. All dividing by 2. This is the solutions of M. Okay. These are the values of M actually. So here we have two different values for it, which are M1 equals and M2 equals. Each one will take one of these. One of them to be negative and the other one to be positive. So this equals 1 plus square root of 3 times square root of 5 dividing by 2, and M2 is 1 minus 3 square root of 5 dividing by 2. Kieszenie, aside. Bu her şey bir kieszenie. M1 and M2 kieszenie. Okay, so these are the values of M. Are these real numbers? Am I real number? جيرة قد وجاك علامة جيرة قد وجاك سالبة نعم قاعدة real. Okay, so these are real numbers but are not integers. They are not integers but they are real numbers. Okay, these are real numbers and they are distinct. Are these two equal? No, they are not equal. So here we say y equals, we write down the solution. Y equals let me write down above. Y equals A e to the power m1x plus b e to the power m2x. That's all. Now we replace m1 and m2. What's m1? 1 plus 3 square root of 5 over 2, and m2 is 1 minus 3 square root of 5 over 2. So y equals A e to the power 1 plus 3 square root of 5 over 2x plus b e to the power 1 minus 3 square root of 5 over 2x. This is the solution. This is the general solution for that second order linear homogeneous differential equation. Okay? Is that easy? Okay. Now we have case 2. For case 2, we said if m1 equals m2, that means we have only one m. For example, in solving x squared plus 2x plus 1. In this equation, if this equals to 0, here we get only one solution. How? If we make it into two brackets, we get x plus 1 in both. So here we get only x equals -1 in both. From both, we get x equals -1. In this case, we have only one solution. That means the solutions are repeated. the solutions are repeated. So in this case, what we do, we say the general solution is on this form. Y equals a plus bx e to the power m1x or m2x, because m1 and m2 are both equal, or mx. This is the solution. So the solution is on this form. If m1 equals m2, that means if we get only one solution. How do you get m1 equals m2? If the terms in the square root is 0. That means if b squared minus 4ac is 0, we get that m1 equals m2. Here we have an example. Now it's solved here. I'm going to solve it here also. We have this differential equation. Y double prime plus 6y prime plus 9y equals 0. Here, we should first write down the characteristic equation. So what's the characteristic equation here? It's m squared plus 6m plus 9 equals 0. You factorize this, or you can use the quadratic law. I'm going to use both, okay? From this, we can say x plus 3, sorry, m plus 3, not x, actually. It's m plus 3 and m plus 3 equals 0. In both, from both brackets, we get that m is -3. So m1, we can say m1 equals m2 equals -3. That's the value. So what's the general solution here? We are going to write down it here. We just replace m here, and that's all. That means y equals a plus bx e to the power mx. What's m? It's -3. That's all. Okay? That's so easy. نعم بخود بيساني أما general form مدراو أنا قلت يسوى منه أما أبي بيساني yes, you should know that. Here we have only 3 cases. For the first case, what we say? We say it equals a e to the power m1x, b e to the power m2x. Okay. For the second case, if m1 equals m2, we say it's a plus bx multiplying by e to the power mx, m1x or m2x, both are equal.
Since the roots are real and equal,
yeah.
How does that affect the equation? We find m anyways.
Yes, you can find it, but the solutions, if you write down as the previous one, we get a e to the power -3x plus b e to the power -3x. Both are equal, both solutions. In this case, we don't have to write down in this form. We have to multiply the second one by x. The second one by x, yeah. You must multiply the second one by x. I can have a show again. Okay, nabit. Okay, a plus b e to the power -3x. It's not equal to this form. Then we have b multiplied by x. Okay. So in the case if m1 equals m2, yes. Okay, let's try the quadratic law. Yeah, a is what? A is 1, b is 6, and c is 9. They must be equal. Let's try. Here we say m1 m2 equals minus b, which is -6, plus minus square root of b squared means 36 minus 4 times 8 times c. 4 times 1 is 4 times 9, 36. Is it? As you see, the terms inside this square root is 0. So here we have no plus minus. Okay. So dividing by 2 times a, which is 2. we get minus 6 over 2, which is minus 3. As you see, both M1 and M2 is minus 3 in both cases. Here, we said before that if b squared minus 4ac equals 0, we said this. We said if b squared minus 4ac equals 0 for this one, that means we have repeated roots. Okay. So this is the solution for that example, and it's solved here also. It's the same as we did. Now we have case 3. In case 3, we say if the roots are on the form alpha plus minus I beta, it means if the terms inside the square roots is negative. If we have, let's say, minus 2, what's this? It doesn't belong to the real numbers. Okay, this is a complex number. It's a complex number, and we can say it equals I square root of 2. Okay, because square root of negative 1 is I. This is I square root of 2. Let's take another example. If you have, let's say, 4 minus 4 in a square root, it equals, for the negative, it becomes I. And 4 is 2, so you get 2I. The result is 2I. Okay? And the general form of any complex number is on the form alpha plus minus I beta. It's plus minus I beta. And here we say alpha plus I beta is the conjugate of alpha minus I beta. Okay? In this case, if the terms inside the square root is negative, we say we use this formula. We use this formula to write down the solution. We say y of x equals e to the power alpha x. Here, this is alpha. It means that's the real part. In any complex number, we have real part and imaginary part. Alpha plus minus I beta. This is a real part. And this is imaginary part. Okay. We say e to the power alpha x. That means e to the power the real part times x, all multiplying by a cosine beta x plus b sine beta x. Here in this formula, we just replace alpha and beta by their values, and we do nothing else. Okay? Here, we just replace alpha and beta. That means we just need to find m. After finding m, we know what's alpha and what's beta. Alpha is the real part, and beta is the imaginary part, the one with I. Okay? Let's try this example. Here we have y double prime minus 10y prime plus 26y equals 0. So the characteristic equation is m squared minus 10m plus 26 equals 0. This is the characteristic equation. To solve this characteristic equation, we cannot factorize. So we use the quadratic law. We use the quadratic law for finding the values of m. And equals minus b. B is minus 10. Minus b is plus 10. Okay? This is the rule. Let me write down the rule. We say m equals minus b plus minus square root of b squared minus 4ac dividing by 2. You should know this rule. Okay? Minus b. B is minus 10. And we have a negative sign also in the rule. So we get 10 plus minus square root of b squared minus 10 squared is 100 minus 4 times a times c. This one. 4 times 1 is 4 times 26 equals sorry, yeah, 104. Yeah, 104. So we get 10 minus plus square root of minus 4, is it? Dividing by 2. So what's minus 4 in a square root? It's 2i. The negative sign becomes I, and here we have 4. The square root of 4 is 2, so you get 2i. As you see here, you get this. Okay. Now we get this. Here it's 2i. This is 2i. If we take it out to the square root, we get 2i. Now, if we take common between numerator terms, we have 10 minus plus 2i. If we take 2 as the common, what's left? 5 minus plus I. Is it? This 2 with the denominator is going to cancel out. And we get 5 minus plus I. We get 5 minus plus I. This is the values of m. This is a complex number. That means it's the third case. Here we should determine what's alpha and what's beta. What's alpha here? Alpha is the real part, and beta is the imaginary part. For the imaginary part, we don't take I, but we take all the others with I. Okay, here we have one with I, one I. That's why it's not written. So beta is 1 and alpha is 5. What we do, we just replace alpha and beta here in this formula by the values. So you get e to the power alpha x means 5x times a cosine beta x plus b sine beta x. Beta is 1. Okay. E to the power real. We solve this example, and it is here in this example we have 2 complex roots. Then we have another example. In this example, we have given 2 initial conditions. We have 2 initial conditions. Y of 0 is 1 and y prime of 0 is 0. The differential equation is y double prime plus 6y prime plus 16y equals 0. To solve this initial value problem, we should first find the solution as we did before. Okay, then we apply the conditions to find the values of A and B, capital A and capital B. Okay, so let's solve this first. First, we should write down the characteristic equation. So the characteristic equation is m squared plus 6m plus 16 equals 0. And here, we cannot factorize this. We use the quadratic law for finding the values of m. We say m1 and 2 equals minus b, which is minus 6 plus minus square root of b squared, 36, minus 4ac, 4 times 1 times 16, which is 48. So it's 64. So minus 64. All dividing by 2a, which is 2. And it equals minus 6 plus minus square root of 36 minus 64 is 28. Is it? It's 28. All dividing by 2. So it's minus 28, not 28. It's minus 28. So the negative sign becomes I. And 28, we cannot find its roots, but we can make it into multiplication 2 numbers that one of them has a square root. 4 times 7, is it? You say m1 and 2 equals minus 6 plus minus 2i square root of 7. Is it? Let me write down here is better. this equals minus 6 plus minus 2i square root of 7. Here, 28 is 7 times 4. 4 from the square root is the square root of 4 is 2, and the negative sign becomes I. All dividing by 2. Here, we can take 2 as the common between the terms in the numerator and cancelling out with the denominator. That means m1 and 2 equals minus 3 plus minus I square root of 7. Is it? If we take 2 from the numerator, we get 3 minus 3 plus minus I square root of 7. Those two are going to cancel out. We get minus 3 plus minus I square root of 7. لسری کرتکه دو به هوا شوره که نگاشه کل تبیتو چی منیتو ناقص 3 زائد ناقص 2 I رجعه. These are the values of M1 and M2. Here we have two complex roots. That means alpha equals minus 3 and beta equals square root of 7. These are the values of alpha and beta. In step 2, we are going to write down the general solution. So we first write down the general form of the general solution for this case. And we have two complex roots. We say y equals e to the power alpha x times a cosine beta x plus b sine beta x. Look, this doesn't equal to that one. That's b and that one is beta. Beta is square root of 7, but b is a constant. Okay, it's okay if someone else write down as this one to be sine and this one to be cosine. It's okay, no problem. Yes. It's the general form of the solution. It's given here. This is second case and this is the third case. In the third case, we say if m equals alpha minus plus I beta, that means if the roots are complex, we use this formula to write down the general solution. We go from this. So you should memorize this. Okay? You should memorize the formula for each case. That's for the third case. And then the solution is y equals e to the power alpha x. What's alpha? Alpha is the real part, and it's minus 3. Minus 3x times a sine beta x. What's beta? It is square root of 7 x plus b cosine square root of 7 x. Here we have beta x. This is the general solution. This is the general solution for the homogeneous differential equation. If the right hand side is 0, this solution is the general solution. Now we use the initial conditions to find the values of a and b. We are going to use the conditions to find the values of a and b. What are the conditions? Here we have given the conditions. If the conditions are not given, we just leave it like this. Here is the final answer. But if we have given the conditions, we must find the values of constants by using the conditions. We have y of 0 is 1 and y prime of 0 is 0. That here we have only y. You see y of x equals e to the power minus 3x times a sine square root of 7x plus b cosine square root of 7x. That's here. This is y. But in the conditions, we have y prime of 0. That means we must have y prime also. We are going to take the derivative for this function to get y prime. Y prime of x equals to what? Here we have multiplication of two functions, e with the brackets. Say first times derivative of the second plus second times derivative of the first. That's how to find the derivative of this function. This is first and that's second. Say first times derivative of the second plus second times derivative of the first. Here we have multiplication of two functions. We get first e to the power minus 3x times derivative of the second function. Derivative of sine is cosine. Here we have a. And derivative of the angle, we get square root of 7 a cosine square root of 7x. This is derivative of this part. Derivative of sine is cosine, and derivative of the angle is square root of 7. And we have a as the coefficient of sine. We get square root of 7 times a times cosine square root of 7x. Then for the second, it becomes derivative of cosine is minus sine. We have square root of 7. This is the derivative of the angle. We have b also sine square root of 7x. This is first times derivative of the second. Then second times derivative of the first. Yeah, right. The second part, as I said, this is the second function. Plus second a sine square root of 7x plus b cosine square root of 7x times derivative of the first one. This is the first one. Derivative of e is itself. So we get minus 3 e to the power minus 3x. Now we have this function for y prime. And then we apply the conditions. We have y of 0 equals 1. It's for the first condition. In function y, we replace each x by 0 and then we equal it to 1. Okay? We say in the first one, in function y, this is y. In this function, we equal each x to 0. This is value of x. And this is value of y. In that function, we replace y by 1 and x by 0. What we get? Yeah, we get 1 equals, this is y. E to the power 0 is 1. E to the power 0 is 1. Because here we have e to the power minus 3x. If we replace x by 0, we get e to the power 0, which is 1. Let me write down it first. E to the power 0 times a sine square root of 7 times x. X is 0, so it's 0. Plus b cosine square root of 7 times x, which is 0. Sine 0 is 0. So this term all becomes 0. And here you have 1, this is 1. And this is also 1. That means it equals to b. So b equals 1. As we said, it equals to 1. B equals 1. No. We apply the second condition first, then we replace b by 1 in it. Let's try the second one. We say for y prime of 0 to be 0, we replace each x by 0 in y prime and we equal it to 0. We equal this to 0 equals 1. This is value of b. And we should find a also. This is y prime that you found here. This is y prime. And this function is y prime. In this function, we replace each x by 0 and we equal it to 0. That means Here, I'm just going to write down the results. E to the power minus 3 times 0 is 1. Here you have square root of 7 times a times cosine 7x, which is cosine 0. Cosine 0 is 1 minus. Here you have square root of 7 times b. Sine 0 is 0. You have sine 0 here, which is 0, plus a times sine 0, which is 0. Sine 0 is 0, is it? Plus b times cosine 0 is 1. All multiplying by minus 3. E to the power 0 is 1. This equals to what? Equals 0. We said y prime is 0. So this is y prime and this is x value. And let's simplify this. We get here we get square root of 7 a minus 0. This becomes 0 plus. Here we get 0 and here we get b. B times minus 3 times 1 is minus 3. Minus 3b. Equals 0. This is the function. And before we found the value of b. B is 1. B is 1. And here we say square root of 7 a minus 3 times 1 equals 0. And so a is 3 over square root of 7. This is a. We found a and b. What we do here in the solution, we just replace a and b by their values that you found. And that's all. That's the solution. Conditions are used for only finding the values of constants in the solution. So a is b is 1 and a is 3 over square root of 7. As you see here, we have y equals e to the power minus 3x. This one. Times a is 3 over square root of 7 sine square root of 7x plus b is 1. So you have only cosine square root of 7x. Let's compare this with the result was given. The coefficient of sine is 7 over 3. The coefficient of cosine is 1. And the angles are square root of 7 times x. And that's the solution. Okay. ليرة لما تشي ماكل هاتي هي كمان بس ساين دانا دو ما بكو ساين دانا أنا ما أنجم من جزء كيشنية بانقص وادامنا وتنبا أو أشكالها بك كيشتانية بويك كان يعني بس ساين دانا كان بكو ساين دانا ياخد أي بي أي ليرة بي ليرة فرقينية. Okay. So this is the solution. Here we say b equals 1. And then we get that. That's the solution. Do you have any question? That's so easy. And here, there's a list of exercise for yourselves. So that's enough for today.